Hello, Algebra 2. Um, as we get started, I just put everything I usually put on the board here. So lessons 24 to 27, our week 7 supplement, and then exam 5 at home. So um, let me know, as always, if you have any questions about anything. And the tutor session is always available on Friday if you need to sign up for that. So as typical, right, we're going to start with our supplement. So last week we talked about quadratics, right? So we talked about quadratics. So let's go ahead and we can say we're going to start on week 7 supplement here. Okay. Okay. And we can scroll up here. Okay. So we talked about quadratics last week. So we said, well, quadratic is like this. It would be y equals x squared, like this, right? And then we plotted x squared. And we also said that actually you could call this f of x, right? Which just means that it's a function of x, right? And we could put something in here. So if we said, well, let's say that we have this quadratic, let's say it's a function of x where x is equal to 0 this time, then obviously that just equals 0. Okay, and then when we plotted these, if we plotted this specific one, we'd end up with a point starting here at 0, 0. Let's go and label our graph here, though. This is the x-axis. This is the y-axis. Okay. And then if we want to label some points here, and we want to use some colors here, let's do 1 and 2 on x here. So -1, -2, so minus 2, down to -2, up to +2. And so if we did x equals 1, so if we did f1 here, we actually made a little table instead, or we had a table on the chart there. That would just be equal to 1, whereas if we did f of 2 or -2, right, we'd have 4. Okay, so we can plot that here. So we say 1, 2, 3, 4. So then we would have this point here on this side of the x-axis. That one doesn't look very correct there. Let's go ahead and redo this point. So this point is right there, and then we end up here at +4 on both sides of the axis here. So if we connected these, we end up with something that looks like this. Okay. Okay, and when we talked about a couple other terms, so we talked about vertex. So vertex was the top or the bottom of our parabola. So it's the top or bottom of the parabola. Top or bottom, sorry, this is another space here, top or bottom of the parabola. Let's see, parabola. So we can see that for this example, right, y equals x squared, our parabola's bottom here, for example, is just equal to 0, 0, where the 0, 0 just refers to the x value and the y value, right? We've learned that with lines as well, right? If we're going to specify a point, we can say the x value, then the y value. So that's this thing right here, right? It's 0, 0. And then the one that I didn't really talk about a whole lot last time was we call a axis of symmetry. So or symmetrical axis. So we say axis of symmetry. You can look at your assignment from last week, but we say axis of symmetry. And you guys can, you know what symmetrical means, right? So our axis of symmetry here is actually the y is along this y-axis here, but actually the axis of symmetry for this we would say is x equals 0. And the reason why we say it's x equals 0, because if we see where this is symmetrical, right? You see on this side over here, right? This is symmetrical to what's over on this side, right? So our axis symmetry is x equals 0. Okay, so now let's go ahead and talk about this week's parabola, okay? We'll talk about vertex and axis symmetry here. So let's go back to color blue maybe. Let's see if I can hide that here. So if I was going to draw something a little different this week, we're actually going to talk about a form here where we have y equals x minus h here, okay, and this is squared. So the thing that's different here is that we have this h. This h is some value, okay, so this will be some number here, some number. And then our vertex here is going to be a little bit different here because we're still plotting the same sort of thing here, but let's actually just look at an example where we put a number there. So if I want to plot here this first example, and I said, well, let's see how it's similar to what I just wrote here, x minus h squared. Instead, I wrote x minus 5, and then we squared that. Okay. Then I could make a table and I could graph it, right? So, for example, let's put some x values, and I'm going to make my table a little bit different here, and I'm going to put it next to this right here. I'm going to say, okay, that's my y value, this is my x value. And now I'm going to think about values I might want to pick. Say, okay, well, the easiest value for me to pick here would be x equal to 5. So x equal to 5, because if I do 5 minus 5 here, and then I square it, that's just going to be equal to 0. Okay, and then what we did before, right, for our stuff last week, we said, well, let's go on either side of our, or we picked x is equal to 0 there, and then we did f of 1, f of 2, right, in this red here on the left side. So let's do something similar here. Let's go ahead and pick, we can pick any value though, right? So there's no wrong or right value to pick. It's just showing you that if I pick on either side of this value of 5, we're going to see a pattern emerge. Okay, so if I pick x equals 6, then I'll have 6 minus 5 squared, which is going to equal 1 squared, which will be equal to 1. Okay, if I pick 4, then I'll have 4 minus 5 squared, right? Which, if I do 4 minus 5, then that equals to minus 1, so I'll have minus 1, but then that's squared, okay? So it's like minus 1 times minus 1, which is going to be 1. Now, let's say I pick 7 instead. So now I'm picking x is equal to 7. Now I'll have 7 minus 5 squared, which is going to be just 2 squared, which will be equal to 4. Okay, so you can see I picked 5, and then I'm picking the values right around 5. Let's pick, instead of 4, let's pick 3. So if I pick 3, then I'll have 3 minus 5 squared, and that will equal to minus 2 squared. Okay, and then minus 2 times minus 2 is 4. So 4. Okay, so you can see my values here. Maybe I should have done in different colors, then you would have been able to see this here. But I have 0 for this value, I have 1 for this value, 1 for this value, 4, and 4. So I'm really mirroring what I did last week. It's just that I have some sort of shift going on here. So let's look at what our shift looks like. So now if we can keep these kind of in mind here, okay, then we'd know that if we started making a plot here, let's do, I'll do my y like this. This is my y-axis, and then my x-axis is over here. So I plotted x equals 5. So 1, 2, 3, 4, 5, 6, 7. So this is 5 here. This is 3 here. And this is 7 over here. Okay. So, and this 3 doesn't look very 3-like, but you know, imagine that's 3. Or I can fix it here. See if I can fix it. There. Okay. Now we can go back to my pencil and we can fix it. Okay, so 3. There. And then on my y-axis, I can label some more. I can say, okay, 1, 2, 3, 4. Okay. So now at 5, I end up with a y value of 0. So that means if I'm going to put these points in here, let's do points in blue maybe, because then we can see the differences, or see the values here. So 5 and 0. So x is 5, y is 0. So that means my point's going to be right here. X is 5, y is 0. And if I go to 6, I'm going to go to y is 1. So that's right there. If I go backwards, right, then I have y is equal to 1 as well, okay? And then if I go to x is equal to 3, so actually I'm going kind of in, I'm actually walking down these as I go. So now if I go to x equals 7, so x equals 7 is right here, okay? And I have y is 4. So I have x equals 7, y is 4. That's going to be up here. And then x equals 3 here, y is equal to 4. So that means that I'm mirroring this over here. So now, if I connect these, right, I'm going kind of like this, oops, like this, okay? Okay, so my graph looks like that. So now, I have something that's a little bit different, right? So let's go back and look at our graph for x squared. So x squared, I didn't have any other numbers here, right? It's just x squared. So I started at 0, 0, so my vertex was at 0, 0, right? X 0, y 0. So now, if I'm going to see where my vertex is here, right, which is part of your exercises starting at number 10, okay, your problems there. If I was going to say what my vertex is, then I say, well, my vertex just got shifted over here, so my vertex is still going to be y equals 0, but my vertex for x is going to be 5. So it's really 5, 0 now, right? Because that's my x value and my y value. So that's my vertex. So if we go back and we think about what my equation looked at the beginning, you can actually see that I have a minus 5 here in my original equation, so y equals x minus 5 squared. So my vertex will be shifted to the right. So you see, right, there's a x minus 5, but I really had to think about what's going to make that in parentheses 0, right, which was my x equals 5. So there are my vertexes there. Now let's think about my axis of symmetry. Okay, so now if I show it like I did in the function above, well, I'm symmetrical about this axis right here, right? So then I can say, well, then my axis of symmetry, and I'm just going to abbreviate this. So axis of symmetry is x equals 5. Okay, because if I go on the left side of x equals 5, so if I go down in numbers here, right, then it's symmetrical compared to this over here. Okay, so when you're looking at some of these where you're going to plot some of these, they want you to make a table of at least 3 points for the first 3 there. right? So if you're going to make a table of at least 3 points, you can pick those values, right? So for that first one, let's write that one out. So the first one, for number 1, okay, let's pick a blue here. So that first one, you have number 1, and it's y equals x plus 4 squared. Well, for that one, then you just have to think about, okay, well, what is different from this one compared to the one here? Well, this one said x minus 5, right? And what I did there is I picked x values equal to 5, so here on this right side. And then, so then if I want this in parentheses to be 0, then I want to pick x is minus 4. So that might be my first point to start with. Okay, minus 4, and then it's basically kind of the opposite. It's not x plus 5, but it's x plus 4. Now, if I'm thinking about writing an equation for my parabolas, right, so let's see if they have an example on the first page there. They actually did, they said write an equation for the graph example number 7. So let's go to example number 7. So example number 7 on that front page, they have a graph here. And let's scroll up a tiny bit. Okay, so they put a parabola there, and they have a y-axis there. They have an x-axis, and I started here at y equals 2, and then they went to 3, and they went to 4. Okay, and then I went up to 1, 2, 3, 4 as well. So I'm up here at 4, and then I have 4 here, 2 there. Okay, and then when they plotted the, oops, I'm just trying to change color here. They had it starting right here, right? And then I went across this point, and then there's this point over here as well. Okay, and actually there's this point here. So hopefully you can see that on that example 7 graph. Okay, so then when I plot this out, I say, okay, well, now I can see that I'm not like a normal parabola, right? Because if it was y equals x squared, I would have started right here at the center part. So I shifted over by 2. So when I shift over by 2, then I say, okay, well that's like, I got to put something in here, right? Say x, and then I got to put minus or plus in here, and squared. So this number is 2. Okay, I shifted over by 2, but did I shift over positive or negative? Well, I shifted over positive. Okay, and how I figure this out, I think of kind of the opposite of this number, right? So then I say it's x minus 2, because if I put a 2 in here, then I get 2 minus 2, I get y equals 0. So you can see that with my equation up here, right? Or with my graph up here. I had x minus 5 squared, so my graph shifted to the right by 5. Okay. And let's say I can't cover all these examples right now, but go look and make sure the other examples make sense. But hopefully you can see this, right? So then if you're going to say what this graph did, you say a couple things about it, right? Say, okay, well, it shifted right by 2. Okay, shifted right by 2. What can we say about its vertex? Well, we could say its vertex is what? Well, vertex is just the top or the bottom of your parabola, right? So if we're just looking at the top or bottom of a parabola, then I'm looking at the bottom of this parabola, right? And I say, okay, well, that's going to be equal to 2 there because my x is 2 and my y is 0. So that's my vertex. And then the last thing I could say is my axis of symmetry. So my axis of symmetry, so symmetry is x equals positive 2, right? X equals positive 2. I can see that, right? I guess I used a different color earlier, right? I used this mustard color. But you can see that if I, whoops, that's not a very straight line, right? I can start here along x equals minus 2, and I can see it's symmetrical this way compared to this way, right? So my axis of symmetry is x equals 2. All right, so maybe you're going to do a couple examples, make sure it makes sense, and then have any questions if you need to refer to the examples there, but I'm always available to answer your questions over email or the Friday session. Okay, let's go to lesson 24, so you can pause the video, or you can go ahead and go along if you already finished maybe an example or two. Okay, so lesson 24. Lesson 24, we're going to talk about fractional equations. Let's see, my pen doesn't always work the way I want it to, but fractional equations. Okay, and overlapping triangles. Okay, so and overlapping triangles. Similarly, we talk about triangles a bit here. Overlapping triangles. So let's just start with an example, and then let's talk about solving it. So let's write out example 1. So example 1, I have 9/2 x, or 9 over 2x, okay? And it's minus 3/5. And then it's equal to minus 5 over 4. All right, so now I can solve this multiple ways, right? I could move my plus 3/5 to the other side, and then I could give it a least common denominator, or make the denominators the same rather. Okay, but one simple way to just eliminate the fractions here, I can identify the LCD. So I could say, well, let's find the LCD. So find LCD for all of these fractions here. Well, my LCD for all these fractions, what number will 2, 5, and 4 go into evenly? Well, it's 2 and 5, that would be 10, but 4 is not, so my LCD is actually 20. Okay, so my LCD is 20. Okay, and then my second step is I can multiply all my terms by the LCD. So multiply all terms by 20. And when I say 20, right, 20 is the same as 20 over 1. So I can write 20 over 1 just to be clear here, okay? And then we'll see what happens here, okay? So let's use a different color to show this. So let's use my red. So I can multiply all the terms by 20 over 1. So 20 over 1. So if I do that, then on this for this first one here, I can think about canceling these, or I can just say, okay, let's just simplify it out the next time. So we'll do 180x over 2, and then for this next term, we have minus 60 over 5. And then this last one, we have 20 times 5, so that's going to be minus 100 over 4. All right, now let's scroll down here and let's simplify. So we can simplify, right? 180 over 2 just becomes 90. So we'll have 90x, or 90 times x, right? That's what 90x means. It's 90 times some value of x that we don't know, okay? And then this one right here is going to be 12, so minus 12. And then over here, it's like I have, well, I have minus 100 over 4, but it's just like I have 100 over 4. Then I'll apply a minus sign to it. So minus 25. Okay. Now it's just isolating my x. So plus 12, plus 12. We've done this before. Okay. You guys should understand this. If I owe somebody $25 and I give them $12, I still owe them $13. So it's minus 13 over here. And my 90x is equal to minus 13, which means I can divide my 90x by 90, okay, by 90. And unfortunately, I don't get a very nice number right because now my x is just equal to minus 13 over 90. I don't really like that weird answer here. But in the real world, you're not going to get super even answers all the time, right? You get some weird answers. So this is still a number. It's just this fractional answer. Okay, so that's those. Okay, and so right, finding LCD, multiplying all terms by that 20 over 1. Now let's go to some similar triangles here. So if I have this, and these are actually nested triangles. So this is a nested triangle. Everything nested triangles. And this is example 4 here. But one recommendation here is just to draw the triangles separately. So draw triangles separately. Okay, separately. So what that might look like is if I have example 4 here. So let's just draw what they gave us. So in example 4, they gave us this kind of this bigger triangle like this. Okay, and then I said this top part here was a smaller triangle. So this one was 4, 7, and then it was 9 here. Okay, and then they said the bottom here was y. They said this part over here was x, and then this part over here was 6. Okay, so pardon my sloppy drawing with my pencil here, but let's see if I can clean this up a little bit. Okay, clean that up here, clean it up here, and clean it up here maybe. Okay, and then I'm going to try to fix this here. Okay, so try to connect my triangle better. Good, looks a little better. So, oh, and then they said that this angle here, they give it a tick mark here, so that means that this angle is similar. And then on this top part, they said this one's also similar. So basically we know that these are similar triangles. So if I'm going to draw them separately, I don't want to stop recording, then I'm going to go down here, and you can draw them separate. So now and say, okay, well then let's draw this small triangle first, or maybe we'll draw the big one. Okay, so let's draw the big one. So the big one, let's see. Okay, kind of like this. If I, on this left side here, I have 6 and I have 4, so that means this side is 10, right? This side over here is a little weird, okay, because you're like, well, it's 7 and x. Well, you can just write this as 7 plus x, and then you can write y on the bottom. Now for this small triangle, we actually know all of our values here, right? We know that this over here is 4, we know this one's 7, and we know this bottom one is 9. Okay, now it looks more like a typical problem that we've dealt with before. Okay, so we can solve separately for x and y. Thankfully, we don't have to like have 2 equations here, but now I have my 2, right? So you see how this worked, right? I pulled them out separately. Now I have these. Now I can solve for them. So now I can say, okay, well, let's do big to small triangle. So I have 10, and it's proportional to 4. And then if I have 10 proportional to 4, then let's start with the easy one. Then I can say, well, then y is also proportional to 9, right? Okay, so now let's solve this one. So I'm going to say, okay, well, we can cross multiply, right? So cross multiply. if I cross multiply here, then I'll get 10 times 9, so that'll be 90, and then it's equal to 4y. And then if I want to finish this, then I say, okay, well then I can just divide by 4 here on both sides. And then 4 here, and then my y is simply, right, because my 4 is canceled there, my y, I could write this, I could reduce this a little bit, right, and then I can say, well, it's 45 over 2. Okay, not a very even answer there, but 45 over 2 is my answer. Okay, now let's go back up here and see what we can do for solving x here. Well, we can still use our same relationships. We can say, well, we know 10 over 4 is still true. Okay, so 10 over 4. But instead of just using our y again, we say, well, then let's look at our x side. Well, it's proportional to 7 plus x over 7. Okay, so then we can say, okay, let's cross multiply this time too. So we can say, okay, then that's 70, and it's equal to 4 times 7 plus x. 7 plus x. And so then we still have 70 on this left side. Over here we have 28. Oops, 28 plus 4x. Now we can subtract 28 from this side because we want to isolate it. So 28 minus 28. Okay, and let's finish this. Then we say, okay, well, finish this up. This becomes 0, right? That cancels. But if I want to subtract this, then I have 42 equals 4x. I can divide by 4 here, both sides. And then I can say, then my x, right, because it's 4 canceled, my x is equal to, and I can reduce it in my head here, 21 over 2. So I don't have really fractional answers here, but that's okay, right? Sometimes I'm not going to get whole number answers. All right, so drawing them separately is a good idea. That way you can see how they're similar. Okay, so if you want to take a pause here and work on some of the practice ones, then we'll go into lesson 25. Okay, so lesson 25 here. Back to blue. Lesson 25. So lesson 25 is about factoring and cancellation. So we'll call it monomial factoring. Okay, so monomial factoring and cancellation. Or I mean, we can even just say canceling, but canceling. Okay, and canceling. So if I think about these things, we've actually talked about greatest common factors, right? So if I talk about a greatest common factor, usually we're used to doing this with numbers. I will write out here, so greatest common factor. We know what factors are, so if I have a greatest common factor, and I'm talking in algebra, I actually have two things. So if I have, let's just go with example 1 here, and then we'll write out something as we go. So if I have 4ax squared, and then I have plus 4xy. All right, so these terms here, oops, I was trying to get a different color here. So I have two pieces, right? I have these numbers here, and then I have these variables here, which I don't know, right? Once you get to algebra, you're like, why do we have to use variables? Well, it's very useful to use variables because we don't always know what our numbers are going to be equal to. Okay, But if I think about the greatest common factor here, I have to think of two things. I have to think of my coefficients. So my coefficients here, so let's say coefficients. Oops, they're not very neat here, but coefficients, okay? And when I think about my coefficients, I think of the greatest common factor of that first, right? So this is the number that divides evenly into those. So it'd be, I would say it's my uh, first number, okay? First number that divides evenly. And I'm going to have to move down here. Evenly into the coefficients. Evenly into coefficients. Okay, we've talked about coefficients before, but these coefficients are these numbers that are in front of my terms here. So I have 4 in both of these, right? So then I say, oh, well, what is the number that divides into those? Well, it's obviously 4. So I could just say, okay, well, then this is just my greatest common factor here for my coefficient would just be 4. So I can just put 4 here. Okay, so that's my coefficients. Now, if I think about number two is actually my variables, okay? So I can find the greatest common factor for my variables as well. Okay, so for my variables, I actually think in similar ways, okay? But I'm selecting the smallest exponent for each variable. So, and that's common, okay? Because it has to be common. That's what greatest common factor means, right? So, what are the common variables between these first two? Well, actually, there's only there's no common a, right? There's a common x, okay? So I'd say that it has to be common, okay? So common and lowest value. So common and lowest value. So in this case, the only common one is x, right? And the lowest value is a single x. So I'd say it's 4x. Okay, so there's my greatest common factor. And then if I take that out, right? So let's draw this in a different color now. Oopsie. So let's draw the rest in blue. Okay, well, let's take 4x out of this first term here, right? So this is this first term here. If I took 4 and I took x out of it, then I just would have a left and I have x left, right? Because if I multiply these two together again, I'd end up with 4ax squared, right? Because there's actually a 1 as a exponent for both of these, okay? And then over here, I'd say plus, and then if I took a 4 and an x out of this second one, then I would just have plus y, right? Because if I multiply these two together, I get 4 xy, like that. Okay, so that would be the answer to that one, right? I just go ahead and factor it like that. Let's do maybe one more, and then we'll move on to our canceling. So let's keep our steps in mind here. So example 3. Maybe write my 3 better. Okay, 3. So I have 4x squared y minus 2xy plus 10xy squared. All right, so now I gotta think of the same thing, right? So if we go back up here, where you can look at your notes, right? If I'm looking for my greatest common factor, I'm looking at coefficients first. So that's the first number that divides evenly into the coefficient. So what is a number that divides evenly into 4, 2, and 10? Well, that would be 2, right? So I could say, okay, then that's 2. So I don't always have to use my different colors here, but I'd say, okay, that's 2. And then I gotta think about my variables. Say, okay, what's common between all these? All these actually have x and they have y, but I gotta pick the lowest value of each one. So not all of them have x squared. All of them have x, right? So then I say, okay, then it's 2x, and then what about my y? Well, one of them has y squared. That last one has a y squared. The other ones just have y, so I would just have 2xy. And then inside here, I'll have 3 terms, okay? And I'll go ahead and use my blue for this, okay? So 2xy, so if I took it out of here, right? Just think about it in relation to this, right? Because I got to multiply to get back to this. So a 2, if I do 4 divided by 2, that gives me 2. So I can write 2. What about x squared and x? Well, I took one x out, so that means that I have a single x here. What about my y's? Well, I have one y up there, and I have one down here, right? So in order to get back, I can't put my y down here, right? Because if I do these multiplied together, I'll get 4x squared y already. Okay, and then this middle one here, you see how I have the exact same thing for this right here as I do up here, right? So when that happens, right, then it means I just have one of those, okay? And then, and that's just because if I do 2xy times minus 1, right, I end up just with minus 2xy. 2x minus 1, and this last one we have plus, and 2 times what equals 10? 5. Or I can do 10 divided by 2, and that'll give me 5 as well. I have 5. I have 1x there, so I divided 1x out, so I don't have any x, and then I have y squared, but I only factored out 1y, so I'll end up with plus 5y, right? And to show you this real quick, okay, let's go ahead and multiply this stuff out here. Okay, so if I want to multiply this out again, I use my distributive principle, right? And I say, okay, do this term times this term, and then times this term times this term. All right, so if I do that, then I just get would do 2 times 2, so that'd be 4, and then I get x squared y minus, and then if I have minus 1 times 2xy, that just gives me minus 2xy. And this last one, 2 times 5 would be 10, so I just get plus 10, and then I had a single x in my 2xy, so that's x, and I had another y, so that gives me y squared, right? So I end up with the exact same thing that I started with up here, right? These are the same things. So that is a way of double checking that what I factored out is correct, right? If I can multiply it back out and get the exact same thing, then I can be confident that I got the right answer. All right. Now let's go on to canceling. So if I cancel, they're just talking about factoring as well. So if I go to example 4, they gave me in A there, they said 6x cubed plus x squared. And then this is all divided by x squared. Okay, and you say, well, I can't do anything, right? Because they're all variables. Well, I can apply my greatest common factor thing. So on the top here, what do I have that's common? Well, my 6, I can't factor anything for my coefficient, right? Because 1 and 6 are the terms here, right? So I can't do anything with those. So I can't factor out any numbers. But both of these have x's, and the lowest term that they have is actually x squared. So I can factor an x squared out, and then I can write 6x plus 1. So hopefully you can see this, right? If I multiplied these out and I distributed, right, then I'd go like that, and I'd have what I originally started with up there. Okay, so I can write that, and then this is all over x squared. So now what I see here is I can keep doing this thing. Right, and then I have x squared on the top, I have x squared on the bottom, which means I can cancel those. And so then finally what I'm left with is just 6x plus 1, like that. Okay, now do one more real quick. Okay, so it just simplifies this out, right? Because it's a lot less to write. So now if I did Same thing, but if I had a little bit different example here, let's say I have 6a squared, and then I have plus x squared over x squared. Well, in this case, let's do the same process here. Is there anything that's common to 6a squared and x squared? And you might be tempted to say, oh, well, they're both squared, right? Well, yeah, except a squared, a is not the same as x, right? So this one, I can't do any cancellation. So they said to cancel, but you say, oh, I can't, right? So this one's like, I can't cancel anything, okay? So can't, or something, I don't know, something like that. You say it's not possible, right? So can't, or you just say not possible, or NA or something like that, okay? Because I can't do that. All right. And then this last thing, okay, I think you guys have seen triangles enough. We don't have to do an example here. They actually don't have an example in the book here. They just show you, okay? But if I said parallel lines, okay, whoops, that A is a little weird here. But parallel lines create similar triangles. I don't think you guys would argue with that, right? But parallel lines create similar triangles. Similar triangles. Whoops, that S is off the page there. But anyway, parallel lines create similar triangles. So you'll see that in your examples in the book there. All right, so if you want to pause right now and work on your practice problems, and then we'll move on to lesson 26. All right, so lesson 26 here. We'll talk about another type of factoring here. Okay, so turn to your page there. It's actually called trinomial factoring. Okay, we'll be doing a bit of this once we get to our supplements as well. So lesson 26, trinomial factoring. So tri just means 3, okay? So trinomial, it's like three term factoring, so trinomial factoring. Okay. And more similar triangles. Yes, there's some similar triangles in here as well. We'll go over that. Okay, I guess I can write that, okay? And similar triangles. If you guys have gone through geometry, you'll probably recognize these right away. They're not much different than the ones we already discussed. Okay, and similar triangles. Now, let's show one here, and then we'll talk about how to set it up. So if I put, actually, let's go ahead and write out a couple steps here. So number one, we're going to set up our trinomial. So we always want to set up our trinomial like this. So we'll say we want to set up with our biggest terms first. We want to set up like this, where we have ax squared plus bx plus c, okay? And where a, b, and c are numbers, okay? Okay, so don't think they're anything crazy here. They're just numbers here, okay? So we're set up like that. And so then we're going to, for our second step here, is not anything special, but we're going to identify what A equals, what B equals, and what C equals, okay? And then step 3, we're going to make a T-chart, okay? So we'll talk about what that is. So make a T-chart. And then our T-chart here is, I don't think you guys have done this before, so I might take a little bit of practice here. But we're going to find two numbers. So find two numbers. Oops, not find. Find two numbers that multiply to a times c. Okay, so those numbers we're finding up there. They multiply to a times c, and they're going to add. Okay, and they'll add to add to that b term up there. Okay, and then one other thing here is that, oops, 5. Last step here, if a equals 1, okay, so that's that term we were just talking about. If a equals 1, then our answer will be, then we'll have something like this. We'll have x plus our first number that we found that multiplied and added to, so we'll have x plus our first number, and then we'll have x plus our second number here. Okay, so we'll see this in reality here in just a second. Okay, so just review, and then we'll come up to here. Right, we want to get our terms in this order, right? Our x squared comes first, then our bx, then our c. Those are numbers. We'll identify a, b, and c, make a t-chart, find two numbers that multiply to a times c, but that also add to b. Right, and then if a is equal to 1, then we'll have this right here, x plus our first number multiplied by, right, so this is a multiplication sign in the middle, multiplication sign in the middle. All right, so now let's go to an example, and then we'll scroll up to see our steps here as well. So example 1, I have, oops, let me get my color here. So example 1, I have x squared minus 5x, so x squared minus 5x plus 6. Okay, so if I have that, right, then actually you guys have seen this before. We did this last year. But let's go back up here, right? So if I have x squared minus 5x plus 6, right, and say, okay, identify the numbers. Okay, well, I can see my numbers here. I guess I could write them out, right? And say, okay, that means that my a number is 1 there, my b number is minus 5, and my c number is just 6. Okay? Okay. And now I need to set up my t-chart. So you guys have done this before, but this is a refresher, right? Then I find two numbers that multiply. What was it again? They multiply to a times c, right? And they add to b. So let's. One thing I like to do in my chart is I actually put mt here. I put multiply to, and then I put adds to. Okay, so I actually sometimes I call it mtat or something. Okay, but it multiplies to a times c. So a times c here in this case is just going to be 6. Okay, so my 6 goes here on my t-chart, and then adds to is my b term. So I'll put minus 5 here. What are two numbers? Can you think of two numbers that multiply to 6, but they also add to minus 5? Okay, and then first thing here, I say, okay, well, let's just think of what multiplies to 6. Well, I know that 6 times 1, right? 6 times 1 multiplies to 6, but if I add 6 to 1, I'll get 7. So that can't work, right? That can't work. Then I can think, okay, well, what about 3 times 2? Well, 3 times 2 kind of works, right? Because that's equal to 6. But it doesn't work over here because that would add to positive 5. So then I say, well, what about minus 3 times minus 2? Well, that would work because 3, if I multiply a negative and a negative, that gets me positive, and it also works over here, right? Because minus 3 minus 2 is minus 5. All right, so I found my numbers. Now over here it says, okay, then if a is 1, which my a is 1, then I can write my answer like this over here. So let's keep that in front of us and we'll write it out. So then I'd say, okay, then that means that I'd have x plus my first number. My first number was minus 3. So I'd say x minus 3, x minus 2. Okay, and that would be my answer. Now, how can I double check this? Well, remember what we did before with our common factoring, our greatest common factoring? We multiplied everything out, right? So if I multiply this stuff out, then I could say, okay, well, let's multiply it out with the distributive principle. I say x squared, and I say minus 2x minus 3x is 3 minus 3x, and then I'd say plus 6, right? And then if I simplified this, I'd have x squared minus 5x plus 6, which is what I had to begin with. Okay, so that checks out. All right, there's another example in the book. I'll refer to that, and you guys can work that one out as well. Okay, but just being careful to set up your t-chart properly, and then you can double check your answer. So let's look at our similar triangle real quick. Might seem like we're talking about triangles a lot when they're very similar. They are, okay, but this one is a right triangle. Okay, so example 5, I have this triangle here where I have this long side and, okay, I can fix my side here. Okay. Okay, I have my triangle like this, and it actually is divided into 2 triangles here. Okay, so I have it like this. And then I have 6 for this one, 4 for this one. This is a square in the corner. This is a square in the corner. And then this one is C. This length is 4. This length they're just calling A. This length they're just calling B. Okay, I think that's all they gave me, right? Yep, that's what they gave me. So it's good practice just to draw them separately, okay? So what I can do is, let's start with the big triangle first. I say, okay, well, this big triangle is not going to be complete to scale because I'm trying to draw it big, okay? But this big triangle on the bottom here is 6 plus 4, so that means that it's 10 on the bottom. On the side we have C, and then over here we have A plus B, right? Makes sense? So that's my big triangle. Now let's draw my small triangle. My small triangle. Oh, one thing I forgot. What did I forget? I forgot to write that it's a right triangle. So right there. That's little things, right? But we'll make sure that we know that's a right triangle because we'll use that later. So my small triangle, it's a right triangle as well. My small triangle is 6 on the bottom, and it's got A for its hypotenuse here, and then on this side it has a 4. Right? So what can I write for these relationships? Well, I should remember that if I'm going to write any relationship, I want to use the same pattern here. So let's work with an easy one first. So I can say, well, what about 10 to 6? If I do 10 is to 6, right? That's my big triangle and my small triangle. Then I can do 10 is to 6 as C is to 4, right? That works. So then if I say that right there, then I can multiply this across, and I say that means that, or I can cross multiply rather. So I can say 6C, oops, my C's, here we go, 6C is equal to 40, or 0. Okay, so 6C is 40. So then to finish this up, I say, okay, then I can divide by 6, both sides, and then my C is equal to, well, I can just reduce this real quick, right? And I say 20 over 3. Okay, so that's my C. Now, I can actually see something in this small triangle already. How can I find A? Well, if I recall the Pythagorean theorem, then it should be pretty simple, right? Because I know that A squared, oops, A squared plus c squared, b squared equals c squared. Okay, this is not to confuse the sides or whatever, right? These right here represent the legs of my right triangle, right? These are my legs. Oh, my G doesn't show up very well because I don't have enough room here. So those are my legs. And my legs are always connected to my 90-degree angle. So that means that if I wanted to find my a squared, so I'm just trying to draw a parallel here, then I'd say, okay, then a squared is equal to 6 squared plus 4 squared, right? Those are my legs. So then I wanted to finish this up here and say, okay, then my a here is going to be equal to the square root of the sum of these numbers, right? So 6 squared would be 36, and then 4 squared is 16. So 36 plus 16, which would be 52. So that means it's the square root of 52. Okay, so now I found a there, square root of 52. Now I can go back up here and I say, okay, then what is my value over here? Well, I found my a, but in order to find my a plus b, I don't really need to use my a anymore because I found c, right? So c is my 20 over 3. So if I want to find a plus b, or I can just call it, I don't know, why don't we just call this a plus b, we'll just call it h for now, okay? This is h for now. So if I want to call that h for now, then I can simplify here and I can say, let's call it h squared. And then if I'm using my big triangle here, then I'd say h squared is 10 squared plus 20 over 3 squared. Okay, this is where you can use your calculator at your advantage as well if you want to. Okay, but that comes out to h is the square root of 100. Okay, right? 10 squared is 100, and then over here I have 400 over 9. It's 400 over 9. Okay, and then I keep on going to see what my other values are there, right? So then if I want to, let's see if I can do this. So 1300 over 9, so my h is going to equal what? I can add those up with my calculator and I can calculate those as well. So I go ahead and calculate that. They came up with a different number there because they combined this over here. So if I want to add these in parentheses here, then I would have 900 plus 400, which gives me 1300 over 9. Okay, let me show you how they did this. I have to explain it to you later. Right? Then if I simplify this, then the bottom will become 3, right? Because the square root of 9 is 3. And then the top here, I could say that this is 100, or the square root of 100, multiplied by the square root of 13. Okay? And then simplify that even further, and I can say that's 10 square root of 13 over 3. All right, now I can use my what I know down here. So my a, okay, but my a plus b, is equal to this value that I just found, right? It's 10 square root of 13 over 3. But I know my a is square root of 52, right? Let's give myself a little bit more room here, right? Because we go back up here, my a plus b, I was just calling this my h just to make it simple, or give it a name actually, right? I was giving it names just so that I could keep track of it. So if I want to solve over here and I say, okay, that means that this is square root of 52, and they still want me to find b, so I say, okay, that's b equals 10 square root of 13 over 3. Then let's go ahead and simplify here. So then I'd say, okay, b then is equal to and subtracting minus root 52 over here, right? Minus square root of 52, and I have 10 root 13 over 3. Whoops, this 3 doesn't show very well. 3, I can fix that in a second. Square root of 52. Okay, let me fix this piece right here. Okay, 10 root 13 over 3. Okay, so now what I can do here, I can say, well, what can I do, right? I actually like to add these together. So we'll get more experience with this as we go along, but you might notice that 13 and 52 have something in common. What is that? Well, 13 will go into 52, okay? So in order for that to be the case, though, I'd want to, maybe I'll write a little more space here. 10 root 13, oops, 13 over 3 minus root 52. Okay, and you can always use your calculator to double check you did the right thing here. But if I multiply this by the square root of 4 over the square root of 4, I'm not actually changing anything with my number here. But if I do that, then I have 10 square root of 52 over 6. Okay, following here, right? So over 6, and then I can subtract square root of 52. So I'm almost there, right? Because I can't add or subtract these just yet, but if I do one more thing, I can. Okay, because now I know that this is over 1, so that means I can make this over 6. I do 6 over 6 multiplied by that, and then I'll get 10 root 52 minus 6 root 52. Oops, root 52. And this is also over 6, right? Okay, and then I'll get 4 root 52 over 6. Okay, and actually I could simplify this even further if I wanted to, but I think I'm gonna go ahead and we'll go ahead and leave it like that. But oh, you know what we could have done? I didn't have to do all of this right here, but we can leave it like that for now. But if I what I should have done is I should have kept my root 52 factored out, right? Because that would have been root 4 root 13, right? So if I do that, then I end up with what? You see how I can change my root 52 like that? Then I'd have 8 root 13 over 6, okay? Which then would simplify to 4 root 13 over 3. That would be my final answer in really long form, okay? But you can see how the book did it. I think they did it a little simpler than me because I wasn't following along with the book there. But they did similar to what I did. They just didn't use as much paper there. All right, so if you have any questions about doing those, make sure you let me know. And we'll just do our last lesson here. So last lesson is 27, so maybe give yourself a minute to work on the practice for 26, and we'll move on to 27. Okay, so 27 is about rational expressions, okay? When we talk about rational expressions here, I'm not talking about the word, what does rational mean, right? And like, what is rational arguments or something like that. When we talk about rational expressions here, it's more like a ratio, okay? So rational expressions, we're talking about fractional expressions in some way, okay? Fractional expressions. It's this ratio part, right? A ratio is really a fraction. Okay, so if I have example 2 here, I think I'm going to scroll down real quick. We can just have less than 27 on here. Okay, then I have x plus 2 over x plus 4, and I have plus 6 plus 2 over x squared. Okay, so if we learn anything about fractions, right, you can say, well, if you're going to add a fraction, you have to have the same denominator, right? Yep, so if you're going to have the same denominator, you got to find the least common denominator, right? So you say, okay, well, what's your LCD here? Well, LCD here, right, is looking at what everything has, or what would be the easiest way to get to the same denominator. Well, in this case, we have x plus 4 for this first one. Nothing is a denominator, which means that we actually have a 1 here. The last one is x squared. So our least common denominator, we'd have to get everything to have x squared on the bottom and x plus 4. Okay. And I messed up here because I don't have enough room here, but x squared, x plus 4, right? Got that? So x squared, x plus 4. Let me fix this real quick. X squared, oops, there we go. X squared, x plus 4. Okay. So that's my least common denominator. Then I have to make sure they all get there, right? So let's just show this here. So that means this first term, I can multiply it by x squared over x squared, right? Because x squared over x squared is just multiplying that fraction by 1. Now for the second one, I have to multiply it by both terms here. So I have to multiply by x squared times x plus 4. I have to do both of those. And I have to do it top and bottom. Okay, x squared, x plus 4. It's not the best way to write this one right here, but I'm multiplying it by 6, okay? Right, and that's what this is right here. And then this last one, I'm multiplying by x plus 4 over x plus 4. I said that backwards, but x plus 4 over x plus 4. Right, so you can see each term here, I'm multiplying really by the number 1. So for this one right here, we'll get x cubed plus 2x squared, okay? And then this next one, I'll get 6. Well, let's actually write this one out here like this. So I get 6x squared. I'll write x plus 4. That way we can do it in 2 steps, and we can see it more fully. Plus 2x plus 8, okay? And then all this is over the same denominator now, right? All this for the denominator is x squared, x plus 4. So that means on the top, we can go ahead and add anything that has a like term. So let's go ahead and write each one of these out. So we have x cubed plus 2x squared plus, and then this one would become 6x to the third, okay? Because you have to distribute here, right? You have to distribute that one, distribute that one. So 6x cubed plus 24x squared, okay? So plus 24x squared. And then we have plus 2x plus 8. And then again, it's all divided by this x squared, x plus 4 denominator. Okay. And you realize, right, I can multiply this denominator out, but I'm just going to leave it like it is because it doesn't need to be simplified right now. So now I'm going to look at my like terms. So I actually have two x squareds right here, right? I have x cubed right here, and then I have 6x cubed over there. So if I add those together, I'll get 7x cubed. What about my x squareds? I have 2x squared over here, and I have 24 of them over there, so that means I have 26 of them, so I have plus 26x squared. Okay, what about my x's? I don't have any single x's, so I'll just end up with plus 2x plus 8. And then it's all divided by x squared, x plus 4. All right, and I think that's it for that one, right? So, yeah, there's nothing else to simplify there. So that's the answer for that one. Now let's go to one more where we have to do a little bit more simplifying before we can do it. Okay, so let's turn our marker back on. So now we have, for example, 3. We have x plus 2, and we have x squared plus 4x plus 3. And then we have minus 1 over x times x plus 1. Okay, so now when we're identifying the LCD, you're like, oh man, this is not really easy, right? Because we want our denominators to be the same. So now we have to factor our denominators. So if we factor the denominator, so factor denominator, so right, factor the denominator. So remember we actually just learned this last lesson, right? We said, well, we can factor our trinomial, right? So we can say, set up this chart, and we say, what multiplies to a times c, right? A times c, and what adds to our b term here, right? So a times c is our multiplied to, adds to is our b term. So we would have 3 here, and we'll have 4 here. Well, that one's pretty easy because I can see that it's actually just 3 and, or 3, oops, not 3 comma 1, but 3 times 1, right? So I can say 3, let's go back here, so 3, sorry, 3 times 1 would be 3, and 3 plus 1 is 4. So now I can just write this first term like that, right? And I can just say x plus 2, and then I can say x plus 3, x minus, or x, this is multiplied by positive 1, okay? Then I say x plus 1. And then I say minus 1 over x times x plus 1. Okay, now it's easy to identify my LCD. Okay, now I can say, okay, now I can find my LCD. My LCD is what? Well, I have x plus 3, x plus 1 in the first one, and then I have x plus 1 in the second one. So my LCD's got to be a combination of both of those. So it has to have x in there, it has to have x plus 1, and it has to have x plus 3. So that means that this first one here, if I can use my colors here, this first one, I have to multiply by x on the top, x on the bottom. And then the second term here, I have to multiply it by x plus 3 on the top and the bottom. So bottom here, x plus 3, top, x plus 3. Oopsie, x plus 3. Okay. And then when I multiply this out, then that gives me x squared plus 2x, right? Because if I think about this, this is like a parenthesis around here. Okay. And then on the top, I have minus 1 times this stuff, so if I have minus 1 times x plus 3, like that, then it's still all over this thing, right? So x plus 3, x plus 1. Then I have x squared plus 2x minus x, and then I'll have minus 3, right? So that becomes what? Well, I can't combine any of my x squareds, right? I only have one of those. Then it becomes x squared, and then plus 2x minus x. So if I have 2 and I'm minusing another one, that just means I'm left with a single x. So plus x minus 3. And then all of this is divided by, you can scroll down here, all of this is divided by x plus 1, x plus 3. And that's my final answer there, okay? And some of these might use different letters and everything, but don't let the different letters confuse you, right? Because some of the examples here you're going to use in practice, you're going to use M versus Z or something like that. So there's nothing different about those. All right, well, that's it. And let me know if you have any questions. If you need to come to the Friday Zoom hours or something like that with any questions, make sure you do that. Just ask questions to your parents or whoever, okay? And I'll see you guys later.